In this video, I will show you how to graph sine and cosine functions with changes in amplitude, changes in period, and phase shifts. In a problem like this, the first thing we need to do is to rewrite this equation a little bit. This b value right here needs to be factored out. So, for example, let me just do this off to the side. Right now we have 2x minus pi. And we need to take that 2 and put it outside of parentheses. And the way we can do that is by dividing everything by 2. And that tells us what will go inside the parentheses. So we will have x minus pi over 2. So this is the form of the equation that we're going to use. All right, this is standard form. So we have y equals -4 sine of 2 times the quantity x minus pi over 2. Now, the amplitude is determined by this number right here. The amplitude is always positive, so the amplitude is going to be 4. The period is determined by the b value. So we use the following formula that the period is going to be 2 pi divided by the b value. So in this case, that means the period is going to be 2 pi divided by 2. So therefore, the period is pi. So the period will be pi. The phase shift is going to come from this number right here. It's going to be the opposite of what you see. So a minus pi over 2 means that the phase shift is actually positive pi over 2. And there is no vertical translation because there's nothing being added or subtracted on the end. So for vertical translation, we can just put none. So to sketch the graph, let's go ahead and draw the x-axis first. Okay, so here is my x-axis. Our first mark will be the phase shift. So I'm going to go ahead and put a mark right here, and I will label it with the phase shift. Okay, so that's going to be pi over 2. Go ahead and put 4 additional marks on the graph. So 1, 2, 3, 4. Since I've created 4 spaces now, each space represents a quarter of the period. So to label them, I'm going to simply add a quarter of a period repeatedly. So since the period is pi, that tells me that a quarter period is going to be pi divided by 4. So what I need to do is I need to take my phase shift and add pi over 4. Okay, so in other words, I need to do pi over 2 plus pi over 4. But in order to do that, I need like denominators. So I'm going to go ahead and multiply this one by 2. So that's going to give me 2 pi over 4 plus pi over 4. You know what? I need to leave myself some room. Let me just move this over so I don't run into my graph over here. Okay, so I've got 2 pi over 4 plus pi over 4. So that's going to give me 3 pi over 4. All right, so that is going to be my first mark. But I need to add pi over 4 again and again and again. So if I add another pi over 4, that would be 4 pi over 4. And if I add another pi over 4, that would be 5 pi over 4. And if I add another pi over 4, that would be 6 pi over 4. So of course I'm going to reduce these as needed. But my next mark we said would be 3 pi over 4. This 4 pi over 4 is just pi. And then I have 5 pi over 4. And 6 pi over 4 becomes 3 pi over 2. All right, so these are the 5 marks that we will use for the 5 key points on our graph. So I'm going to put an additional mark over here to the left. I need to determine where the y-axis goes. I'm going to pick a different color so we can easily remember that this is where we started. So I think I'll do purple. All right, so I'm going to make another mark over here to, I'm going to do green. I'm going to make another mark over here to the left. Okay, now because I'm going to the left, that just means instead of adding pi over 4, this time I'm going to subtract pi over 4. So if I do 2 pi over 4 minus pi over 4, that's going to be pi over 4. So if I go 1 mark over, that's going to be pi over 4. Now I need to keep going until I get to a negative number. So I'm actually going to go another mark over. Okay, stretch that out a little bit. So obviously if I subtract pi over 4 again, that'll be 0. All right, so this would be 0. But the 0 tells me that that's where the y-axis goes. So instead of even writing 0, I'm just going to go ahead and put my y-axis right here. Let's see, I think I'll cheat and use an actual line for this. Okay, so here is, whoops, my y-axis. Okay, now we have to think about the amplitude. So since the amplitude is 4, then on the y-axis I should be doing positive 4 and negative 4. Okay, so now we're ready to actually draw the graph. So now we're ready to start the actual graph. We have memorized that a sine function starts off at the midline. So that tells me that my first dot is going to go here. Again, notice I'm not starting at the y-axis. There has been a phase shift. So this first period of the function is going to begin at pi over 2 because that was the phase shift. Normally, the sine function goes up from there. But because there is a negative sign here, that means I have a reflection over the x-axis. So instead of going up first, this is going to go down first. All right, so this function is going to go here, and then here, and then here, and then here. So this would be a good sketch of this sine function. For problem number 10, we first need to rewrite the function to see what the phase shift really is. The phase shift is not pi over 4. We have to take this b value and pull it outside of the parentheses. So we're going to rewrite this. All right. So I'm focusing on the 1/2 x minus pi over 4 part. If I put the 1/2 outside of the parentheses, Then inside I'm going to have x minus, and to see what that last number is going to be, I need to take the second number and divide it by 1/2. So I'm doing pi over 4 divided by 1/2. So when you divide by a fraction, you multiply by the reciprocal. So this is going to be pi over 4 times 2. So that would be 2 pi over 4, which reduces to pi over 2. So that is what goes right here. So this is another version of this function would be y equals 1/2 cosine, and then all of this. All right, so now we can go ahead and answer these questions. All right, so looking at this version of the equation, the amplitude is going to be 1/2 because of this right here. So the amplitude is 1/2. Let's talk about the period. The period is 2 pi divided by the b value. The b value is the 1/2 that's right here. So it'll be 2 pi divided by 1/2. Well, when you divide by a fraction, again, you multiply by the reciprocal. So this will be 2 pi times 2. So therefore, the period will be 4 pi. Now, the phase shift, we can now see that the phase shift is going to be pi over 2. Notice that it is the opposite in terms of the sign. So since I have minus pi over 2, then the phase shift is positive pi over 2. There is no vertical translation because nothing is being added or subtracted on the end. So for vertical translation, we can just put none. All right, and now we're ready to start the graph. The first mark on your x-axis will be the phase shift. So I'm going to put my first mark right about here, and I will go ahead and call this pi over 2. Now I need to put 4 additional marks on the x-axis. So I think I'm going to stretch this out a little longer. So 1, 2, 3, 4. So this will be one period of this function. Since I've divided it into 4 equal sections, each section is a quarter of a period. So what I need to do next is calculate how big is a quarter of a period. And then I can use that to find the additional markings. So, well, this time it's going to be pretty easy. Since the period is 4 pi, then the quarter period is just going to be 4 pi divided by 4, which is simply pi. So pi is a quarter of a period. So what I need to do is I need to take my phase shift of pi over 2, because that's my starting place. To get to the next mark, I need to add pi to that. Now, I need like denominators, so we can just go ahead and call this 2 pi over 2, and that's really the same thing. So if I add this, 1 pi over 2 plus 2 pi over 2 is 3 pi over 2. So that's going to be the next mark, but let's keep going. Because I have 2 more marks to go. Well, 3 more marks to go. So if I add another 2 pi over 2, that would be 5 pi over 2. If I add another 2 pi over 2, that would be 7 pi over 2. Add another 2 pi over 2, and that's 9 pi over 2. So these are the marks, the values that will go on the x-axis. Okay, so here I have 3 pi over 2 and 5 pi over 2, 7 pi over 2, and 9 pi over 2. Sometimes you have to reduce, but none of these happen to reduce. Now I need to see exactly where to put the y-axis, so I'm going to put at least one mark to the left so I can figure out where the y-axis will be. Now I'm going to change colors. I'm going to put this mark in purple to make it clear that this is not one of the 5 marks that I'm going to use to graph the key values. This is sort of extra. Now, when I was going to the right, I was adding 2 pi over 2. So if I want to go to the left, I'm going to subtract 2 pi over 2. So if I do minus 2 pi over 2, all right, 1 pi over 2 minus 2 pi over 2 is negative pi over 2. So that's what this mark will be. 1 to the left is negative pi over 2. Okay, so now we can see that the y-axis must be right here. It has to be between a positive and a negative because the y-axis is always at 0. Okay, so here is my y-axis. All right, now I see that the amplitude is 1/2. So that's why I'm going to put 1/2 right here, and I'm going to come down here and I'll mark this as negative 1/2. Okay, so this is a cosine function. So we know that the cosine function starts off at its highest value. So remember, the phase shift is pi over 2, so that's where the first dot will go. And then the cosine falls to the midline, and then it goes to its lowest value, then back to the midline, and then back to its highest value again. So this graph of the cosine function should look something like this. Okay, and that is it. All right, so that was problem number 10. Problem number 11 is a little bit extra easy because there is no phase shift. There's no horizontal change. So the amplitude is going to come from the -2. So I'm just going to put +2. Amplitude is always positive. The period, now there is a b value right here, so I know that the period is going to be 2 pi divided by that b value. So I have to multiply by the reciprocal, so this will be 2 pi times 2, so therefore the period is going to be 4 pi. So the period is 4 pi. There is no phase shift, so I can just say none. Vertical translation, nothing is being added or subtracted. So again, I will just say none. So this graph is going to be relatively simple. So let's just go ahead and draw the x-axis. Okay, so there's my x-axis, and might as well go ahead and draw the y-axis too. Since there's no phase shift or anything, nothing crazy is going to happen. All right, so I have my x-axis and my y-axis. Now the amplitude is 2, so I can go ahead and say 2 and -2 on the y-axis. Now I'm going to come out to here and I'll go ahead and call this 2 pi. Since there's no, well, no, that's wrong. The period is 4 pi, so if I jump to the end of the period, which is what I'm doing, this should be 4 pi. And then if I go to the middle, that should be 2 pi. And then of course half of that will just be 1 pi. So you can see the pattern, 1 pi, 2 pi, 3 pi. So now we've labeled the x-axis. A cosine function normally starts off at its highest point and then falls. However, the negative sign in front means there's a reflection over the x-axis. So this cosine function is going to start at its lowest value and then go up like this. And that's really it for the graph for problem number 11. All right, for problem number 12, the amplitude is going to be 2, because I see the 2, the A value in the front. The period, there is no B value. The B value would be sitting right here. There is no B value. That means the period is going to be the usual 2 pi. Phase shift. Because there's no B value, I can just look and immediately see the phase shift from this value right here. So because this is positive pi over 2, I know that the phase shift will be negative pi over 2. Vertical translation, there is none because nothing is being added or subtracted on the end. So we are really ready to draw the x-axis, so let's go ahead and do that. Okay, so here is my x-axis. We should put our first mark on the x-axis at the phase shift. So the first mark is going to be negative pi over 2. Now put 4 additional marks. 1, 2, 3, 4. Since I've created 4 spaces, each space is a quarter of the period. So therefore, we can find out the other values by adding a quarter of the period. So, well, the period is 2 pi, so that means a quarter of the period is going to be 2 pi divided by 4. And that reduces to pi over 2. So what I need to do is take my original phase shift, which is negative pi over 2, and I need to add the quarter period. I need to add pi over 2. Well, that's going to give me 0. Okay, so that tells me that the next mark is going to be 0. But then I need to just keep doing that 3 more times. So if I add another pi over 2, 0 plus pi over 2 is pi over 2. So I have pi over 2. If I add another pi over 2, that would be 2 pi over 2. But that reduces down to simply pi. If I add another pi over 2, that's going to be 3 pi over 2. So I will have 3 pi over 2 here. So that's half the battle is just labeling the x-axis properly. Now the y-axis always goes at 0. So since I actually have a 0 right here, I can go ahead and just put the y-axis right there at 0. Okay, sometimes the y-axis is not one of our 5 marks, but in this case the y-axis is right at the second mark. So just be aware of that, stay aware of that. We should label this y-axis. The amplitude is 2, so for that reason I'm going to call this 2 and I will call this -2. This is a sine function. The sine function starts off at the midline, and because of the phase shift, the first point we're going to graph will be at -π/2. So the sine function goes up and then down. So at the next quarter period, I'll be here, and then here, and then here, and then here. So this is what the graph should look like for number 12. Soak it in. Problem number 13. I can see that the amplitude is 2 because of the 2 right there, so kabam. The period, there is no b value, which the b value would be right there. So there's no b value, so the period will be the usual 2 pi. There is a phase shift, but since there's no b value, I don't have to do any fancy math. I can just see the phase shift right here. It will change signs though, so since I have plus π/2, I know the phase shift will be actually -π/2. Aha, this one does have a vertical translation. All right, so there's a vertical translation. This is going to be down 3. So I'm just going to write down 3 right here. All right, let's go ahead and draw the x-axis. I think I'll draw the x-axis up higher than I normally do. Since I know I've got to go down 3, might as well put it up a little bit higher. Okay, now let's go ahead and talk about the phase shift. Since the phase shift is -π/2, that's where we will put our first mark on the x-axis. So we'll go ahead and put -π/2 right here. Now let's go ahead and put 4 additional marks. 1, 2, 3, 4. Since I've created 4 spaces, each space represents a quarter of a period. So to find the other labels, I can just start with -π/2 and add a quarter period each time. So what is the quarter period? Well, since the period is 2 pi, that means a quarter period is going to be 2 pi divided by 4, which reduces down to π/2. So I need to take my initial -π/2 and I need to add π/2. Well, that's going to make 0. All right? Now, so that's going to give me the first mark, well, the next mark. Now, I'm just going to repeatedly add π/2 to get the other 3 marks. So if I add π/2 again, I'm just going to get π/2. So that'll be the next mark. If I add π/2 again, that'll be 2 π/2, which is just pi. If I add π/2 again, that'll be 3 π/2. So these are the 5 marks on the x value that I'm going to need. So this is a special case. Very often the y-axis is not right on one of these marks, but in this case we have 0. So the y-axis will actually be right at 0. So I'm actually going to erase the 0 because I'm just going to put the y-axis right here. Alright, so here comes the y-axis. Kabam. Now we have this vertical shift going down 3. So I'm going to go 1, 2, 3. So here I am at -3. Now the amplitude is 2. So that means I'm going to need to go 2 up and 2 down. Actually, let's go ahead and put a dotted line representing the midline. All right, that's important. Okay, now if I go up 2 from here, that's going to be at -1, so that should be labeled. If I go down 2 from here, that's going to be at -5, so that should also be labeled. Okay, now we are ready to do the graph. The sine function starts off at the midline. Please remember that we're starting at the phase shift. So the first dot goes at the midline, and it's going to go at -π/2, the phase shift. And then the sine function goes up and down and back. So the next dot should be at the high point, all right? And because of the amplitude, we're going up 2. And then it falls back to the midline, and then it's going to go down 2, and then back to the midline. So this is what the graph should look like for number 13. All right, so it's very important that you have -1 and -5 and -3 all labeled. All right, so last one, number 14. We are going to have to rewrite this a little bit in order to see the phase shift properly. So I'm focusing on the part that says 1/2 x plus π/2. We need to factor out the 1/2 outside of parentheses. So what we're really doing is we're dividing everything by this number. So I'm dividing this by 1/2, and that's why it's just x. But I'm also dividing this by 1/2. And that's what's going to tell me, that tells me what will go in the second position. So how do I do that? Well, when you divide a fraction by a fraction, you multiply by the reciprocal. So this is really going to be π/2 times 2/1. Okay? So those 2's cancel each other out, so it's really just going to be pi. So the rest of the function, I'm just going to wrap around this. So we have, this was cosine, and this was a 4. So this is the function that we're really dealing with. So in this form, we can more easily see the phase shift. Anyway, the amplitude is 4 because of that 4 right in the front. The b value of 1/2 leads us to the period. We remember that the period is 2π/b, so that's 2π/1/2. So we have to multiply by the reciprocal, so this will be 2π times 2, which is 4π. So the period will be 4π. Now the phase shift is right here. It will just be the opposite sign. So because it says plus pi, that means that the phase shift is -π. There is no vertical translation because nothing is being added or subtracted. So we're just going to say none. So we can go ahead and make the x-axis now. So here's my x-axis. Now, our very first mark on the x-axis should be the phase shift. So I'm going to put a mark right here and call it -π. Then you want to put 4 additional marks like this. 1, 2, 3, 4. Because I've divided the x-axis into 4 sections, then that means each section is going to be 1/4 of the period. So let's calculate exactly how big that is. So the quarter period, QP, is going to be the period divided by 4. So that's going to be really simple in this case because 4 pi divided by 4 is just going to be pi. So that means the quarter period is going to be pi. So to find the next mark, I just need to take my initial phase shift and add the quarter period. So I'm just going to add pi. Well, that comes out nice and easy because that's just going to be 0. And then if I add pi again, that's going to be pi. And if I add pi again, that's going to be 2 pi. And if I add pi again, that's just going to be 3 pi. So this is going to be really nice and simple. So I will have 0, pi, 2 pi, 3 pi. The y-axis is always at 0. So very often the y-axis winds up between these marks, but in this particular case, the y-axis is going to be one of the 5 marks. So let's go ahead and draw the y-axis right in here. Okay, so here's my y-axis. Because the amplitude is 4, I'm going to label this 4, and I'm going to label this -4. So we're ready to do the graph. The cosine function starts off at its highest value. But remember, I'm not putting my first dot on the y-axis. There's been a phase shift that is pi to the left. So your first dot will always go at the phase shift, which is here. And then I'm going to do the normal fall and rise of the cosine function. So the second dot will be at the midline, and then it will be at its lowest point, and then back to the midline, and then at its highest point again. So this cosine function for problem number 14 should look like this. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.